Okay, today's video deals with the geometry problem when given similar altitudes, and which in this case they're giving you this kind of a symbol here, which is like a proportional thing, and it's saying that triangle XYZ is similar to triangle BCD, and YS in the smaller triangle and CE in the larger triangle are altitudes. Solve for X. Now they give us some information here along this, and I don't know if you could see it in the print, so I'm going to add it in. This is 9. This is 2x minus 15. This is 54. This is 34. This is 39. Okay, X, Y, Z, S, B, C, D, E. Okay. First, it remains that we have to first define what this similar triangles means, and then from that flowing this similar altitudes when they're positioned from the same vertice. Okay, so let me just say that within this X is kind of vertice is corresponding to B. Y vertice is corresponding to C, and Z vertice is corresponding to D. So if you see X and B, Y and C, Z and D. And so the vertice that this altitude is emanating from is the corresponding vertice. So with that being said, that makes, since these are similar triangles, these are similar altitudes in this respect. What is similar? Well, as you can see, if these triangles are similar, they're surely not the same size, so that would be congruent in size and angles. Sides equal, corresponding sides equal, and angles equal. And in this case, I have only angles are equal. Okay, so what it means to be similar is that the corresponding vertices, the ones that are actually related for this similar to take place, means that the angle of the two sides coming out of that vertice are equal. The angles are equal, so this C angle and Y angle are going to be equal. The D angle and the Z angle are equal. The X and the B angle are equal. And it doesn't mean that the sides are equal, but it does mean that the angles are equal. And that's what makes them similar. Otherwise, you'd have two different triangles. But they're not congruent, because congruent would be same sides, same angles. Similar, same angles, different sides. Okay, so proceeding with this problem, the first task is to, well, we have to find X. That's the overall task. Okay, now that we've established these are similar altitudes, what does it mean to be an altitude? Well, when you're thinking in terms of a plane, okay, if you're at B and you see a plane at C, the altitude of that plane is not the line from B to C. The altitude of the plane is the distance that the plane is above the Earth's surface. So that means you'd be taking a line straight down, and that line would form a 90-degree angle with the Earth's surface. So that's the altitude, and that's why they call it an altitude. Same thing if you're an observer at D and you're looking up at the plane at C, 39 is not the altitude of the plane. This distance here, CE, is the altitude. That's the distance above the ground, which would be this base here. All right, so let's look at what we need to solve this problem. Well, we have this here, so we need this side to correspond to that side. We don't have this side either to correspond to the 39. But there is something I see here. I have the distance between here and here. Okay, and this is 54, and this is 34. So I know that this E to D must be the difference between 54 and 34, which would be 20. So I got that so far. Now I see this CED is a right triangle, and I can employ the Pythagorean theorem. So, in other words, we have x squared plus y squared equals r squared. And in this case, this would be my x, this would be my y, this would be my r. Or otherwise, you would see on each side of the right angle are these things we call legs. These are the legs of the triangle. And over here would be the hypotenuse. Okay, so the legs straddle the right angle, and opposite the right angle is the hypotenuse. So with that being said, I'm just calling this x for now for simplicity because it's on the x-axis, and this is on the y-axis, and then there's my r. So I say x squared, y squared, r squared. So let's put it in. What do we get when we put this in? Well, we got 39 is squared over in the r position. The x is 20 squared. And then the y, we don't know. So that's what we're after. So we want to get that y right there. Okay? So let's see. With that, we need y. We could then figure out y over to the corresponding 2x minus 15. Okay, so let's see what we get here. 39 squared. 39 squared. 1521. 1521. 20 squared. 20 squared. 400. 400 plus y squared. Excuse me. Y squared. Okay. Minus 400. Minus 400. Bring that over there. I get y squared equals 15. See if I can get a minus sign in there. Plus 1521. So equals 1121. Take the square root of that. It'd be plus or minus 33.5. But in this case, distance is always plus, so it would be plus 33.5. So there's our y over here. So this is 33.5. Okay, now we could associate that over to this if we had this thing called k, and that's the proportionality factor. Proportionality factor. Okay, so that is the factor that relates the size of the sides of these two triangles. Well, to get that, we just have to compare any corresponding sides that we have the same, and we can get the factor. And I have a 9 here, and I have a 20. So these are corresponding sides of this ECD SYZ triangle. So I would say the big over the small. I always like big over small, so I would put 20 over 9, and that's the proportionality factor. So I have k equals 20 over 9. So now, doing the same thing, big over small, I'm going to compare this side, CE, which is the altitude, to the other altitude. And, of course, these two are related to the proportionality factor, which is k, which happens to be 20 over 9 from associating the other two corresponding sides to the ones that are unknown. So we figured out 33.5 over here. So the big is 33.5. What's the small? Well, the small is 2x minus 15. Okay, so now we have an equation, and we could solve that equation. We get x. So bring this cross multiply is 20 times 2x minus 15 equals 9 times 33.5. Okay, running some numbers. 33.5 times 9. I get 301.3. I'll carry one decimal place. This will be 40x. And minus, what's 20 times 15? I said 2 times 15. 20 times 15. 300. Okay, now add these together. Plus 300 equals 300. And I get 300.0. This will be a minus. No, a plus. And I add them together, right? Both sides. So now I end up on this side. Let's bring this over here. I get 40x equals 601.3 plus 601.3. And then divide it by 40, and I get x equals 15.0, so x equals 15. And that's the end of that problem. There's another one like it, but this shows you the solution of this type of problem. Thank you.